You've probably seen those AI-generated videos floating around online. Some look amazing, others are, well, let's just say they're a bit wonky. Maybe you've even tried making your own and wondered why the physics seem off, or why there's no sound. Well, OpenAI just dropped Sora 2. And here's what's surprising. This isn't just another incremental update. This is the moment AI video went from impressive tech demo to something you might actually want to use. Welcome back to bitbiased.ai, where we do the research so you don't have to. Join our community of AI enthusiasts. Click the newsletter link in the description for weekly analysis delivered straight to your inbox. So in this video, I'm going to walk you through exactly what makes Sora 2 different from its predecessor and every other AI video tool out there. We're talking synchronized audio, physics that actually makes sense, and a feature that lets you put yourself into any scene you can imagine. By the end of this, you'll understand not just how this technology works under the hood, but what it means for creators, filmmakers, and anyone who's ever wanted to bring their ideas to life in video form. Let's start with where this journey began, because the leap from Sora 1 to Sora 2 is bigger than you might think. From Sora 1 to Sora 2. Think back to December 2024. OpenAI described the first Sora model as the GPT-moment for video, essentially a proof of concept that said, hey, we can generate video at all. And it was impressive for what it was. You could create roughly 20-second clips in 1080p across various styles. But here's the thing, it had some pretty glaring limitations. Objects would mysteriously flicker in and out of existence. Physics? Let's just say gravity was more of a suggestion than a rule. Objects could literally teleport across the screen instead of following basic physical laws. And perhaps most noticeably, everything was completely silent. Now, fast forward to September 2025. OpenAI isn't calling Sora 2 the GPT-2 moment of video. No, they're positioning this as the GPT 3.5 moment. A massive leap that transforms the technology from interesting experiment to genuinely useful tool. So what changed? Let me break this down in a way that'll make sense whether you're a developer or just someone curious about where AI is heading. First, and this is huge, Sora 2 actually understands physics. I don't mean it kind of gets physics. It genuinely models real-world dynamics and even failure states. Picture this. A basketball player takes a shot and misses. In the old model, you might see some weird teleportation or the ball magically finding the basket anyway. With Sora 2, that ball bounces off the rim exactly like it would in real life. The model can handle complex scenarios that completely broke earlier systems. We're talking gymnastics routines with proper momentum, paddleboard flips that respect buoyancy, figure skaters performing triple axels while somehow keeping a cat balanced on their head. Yes, that's a real example from their demos. But wait, it gets better. Remember how I mentioned the original Sora was silent? Well, Sora 2 changes that completely. This new model generates synchronized audio, and I'm not talking about some generic background music slapped on afterward. We're talking realistic dialogue, ambient soundscapes, and sound effects that actually match what's happening on screen. Characters can speak lines you write in your prompt. You hear footsteps when someone walks, splashing when they hit water, wind rustling through trees. The audio and video are created together, in sync, from the ground up. Here's where things get really interesting for storytellers and creators. Sora 2 excels at what OpenAI calls multi-shot coherence. You can now write prompts that span multiple scenes, and the model will maintain consistency from clip to clip. Imagine writing something like, Day 1, 2 astronauts land on Mars. Day 2, a dust storm approaches. The old Sora would struggle to keep those astronauts looking the same, maintain the same Mars environment, or even remember what happened in the previous scene. Sora 2 tracks characters, environments, and narrative threads across multiple shots. This persistence of world state, this memory of what came before, was practically impossible with earlier models. The aesthetic range has expanded dramatically too. Whether you want photorealistic cinematography, anime-style art, or something completely unique, Sora 2 delivers with sharper textures and finer detail than its predecessor. The lighting feels more natural, the colors more vibrant, the overall visual fidelity more, well, real. And then there's the feature that honestly feels like science fiction. Cameos. You can upload a short video of yourself, just a quick clip with audio, and Sora 2 captures your likeness and voice. From that point forward, you can generate videos with yourself in them. Not some generic avatar that kind of looks like you, but actually you, inserted into any scene you can imagine. Want to see yourself rocketing across the sky? Dancing with Bigfoot? Having a conversation with a cartoon elephant? It's all possible. And before you worry about deepfake concerns, which is totally valid, OpenAI has built in strict controls. Your Cameo is yours. You control who can use it, and you can revoke permission or delete content at any time. What OpenAI is really saying with all these improvements is that video AI is moving closer to being what they call a world simulator, a model that genuinely understands how the physical world works and can recreate it convincingly. These aren't just incremental improvements. They're the kinds of things that were difficult for prior video models to achieve, as their technical documentation puts it. How Sora actually works under the hood. Now you might be wondering, how does any of this actually work? I know. We could just use it without understanding the technology. But trust me, knowing what's happening behind the scenes makes you so much better at prompting and getting the results you want. Plus, this stuff is genuinely fascinating. While OpenAI hasn't revealed every detail about Sora 2's exact architecture, they're pretty secretive about model size and compute resources. We do know it builds on the original Sora's transformer diffusion design. Think of it as a latent video diffusion model with a transformer backbone. If that sounds like technical jargon, stick with me for a moment, because I'm going to explain it in a way that actually makes sense. Imagine you're trying to send a high-definition video file to a friend, but your internet connection is terrible. What do? You compress it, right? That's essentially what happens in the first step of Sora's process. A neural encoder takes each video frame and compresses it into what's called a latent space, a lower dimensional representation that captures all the important visual information while dramatically reducing the computational load. It's like taking a massive file and condensing it down to its essence without losing what makes it meaningful. Here's where it gets clever. Once the video is compressed into this latent space, Sora chops it up into smaller space-time patches. Think of these like JPEG blocks, but across both space and time. Each patch becomes a token, similar to how words become tokens in language models like GPT. This unified representation is brilliant because it means Sora can train on videos and still images of any length, any resolution, any aspect ratio. Square videos, vertical videos, horizontal videos, it doesn't matter. They all get converted into this standardized patch format. Now comes the diffusion part, and this is where the magic happens. Sora is what's called a diffusion model, which means it learns to generate video by starting from pure noise and gradually removing it. Picture static on an old TV screen. That's where every video generation begins. Complete chaos. Then, step by step, a large transformer network predicts how to denoise those patches, guided by your text prompt. It's like watching a blurry image slowly come into focus, except it's happening across time as well as space. The transformer itself, and this is key, uses multi-head attention to look at all the patches simultaneously. It can see how objects move across time, track relationships between different parts of the frame, and maintain long-range dependencies. OpenAI explicitly compared this to GPT models, noting that, similar to GPT models, Sora uses a transformer architecture, which enables superior scaling performance. In other words, the same architecture that revolutionized text AI is now revolutionizing video AI. Finally, after all that denoying, a decoder network takes those clean latent patches and reconstructs full-resolution video frames. And in Sora 2, there's an audio generation component running alongside this process, likely using a parallel diffusion approach conditioned on the video latents to produce matching sound. What's particularly interesting is that this whole approach builds on techniques from both DALL-E and GPT. OpenAI uses something called recaptioning, generating detailed descriptive captions for training videos and images to improve how well the model follows text prompts. This is why Sora 2 is so good at understanding exactly what you're asking for. As for what's specifically new in Sora 2 under the hood, that's where things get murky. The Sora 2 system card focuses almost entirely on safety rather than technical architecture. But analysts who've studied the outputs infer that Sora 2 is essentially a scaled-up version of the original, trained longer on vastly more video data, with likely enhancements like better temporal attention mechanisms and possibly hierarchical diffusion to handle longer sequences. The proof is in the results. Better physics understanding, longer coherent sequences, and that integrated audio system. The capabilities that change everything. Let's talk about what all this technology actually enables, because understanding the what is more important than the how for most creators. I'm going to walk through the standout features in a way that shows you not just what they do, but why they matter. Physics that finally makes sense. Remember those old AI videos where characters would float through walls or objects would do impossible things? Sora 2 understands inertia and collisions. When you watch demos of skateboarding or gymnastics, the flips land correctly. When characters tumble, they respond naturally to walls and water. This is what OpenAI means when they talk about modeling outcomes rather than forcing success. If a shot misses, the model doesn't magically fix it. It shows you what would actually happen. The ball bounces off the backboard, a person slips and falls. It's this attention to failure states, not just success, that makes the physics feel real. For creators, this means fewer glitches, fewer impossible poses, and videos that don't break immersion with weird artifacts. Audio that actually syncs with video. This might not sound revolutionary until you've tried to manually sync audio to AI-generated video. Sora 2 can generate speech and sound cues that perfectly match the visuals as they're created. A character can speak lines you write directly in your prompt, or the model can invent natural-sounding conversation on its own. Background sounds, rain pattering on windows, crowd noise in a stadium, the rumble of an engine, are all generated on the fly. In the demos, you can watch talking characters and hear them speak with different accents, all AI-generated, all perfectly synchronized. This cuts out an entire production step that used to require separate tools and manual editing. Continuity across multiple scenes. With most AI video tools, you'd get two completely different-looking detectives, different lighting, maybe even a different art style. Sora 2 maintains the detective's appearance, camera style, and overall aesthetic across shots. Characters stay consistent. Lighting remains coherent. This is absolutely critical for storyboarding or creating any kind of narrative content. Creative control that feels natural. Sora 2 remains fundamentally prompt-driven, but the level of control has increased significantly. Need a cozy Sunset Park scene? Describe it. Want a high-octane car chase? Just say so. What's interesting is that users are reporting success with advanced edits, asking the model to change specific objects in a scene or tweaking lighting conditions. OpenAI calls this enhanced steerability, and it means fewer vague, unpredictable results. You can even feed the model a still image and ask it to animate or extend it, turning photos into living, breathing scenes. The Cameo feature deserves its own spotlight. After a one-time identity verification, think selfie video and voice sample, Sora 2 captures your three-dimensional likeness. In subsequent generations, the AI renders you into any video you create. This isn't a static face-paste job. The The model adapts your clothing, hair, and even gestures to fit naturally into each scene. In one demo, an OpenAI researcher's Cameo appears interacting with a cartoon elephant, and it looks completely natural. The key here is control. You specify exactly who can use your Cameo, just you, specific friends, or everyone. And you can revoke access or delete content whenever you want. What this actually looks like. The visual quality is stunning. We're talking photorealistic tigers in apple orchards with natural lighting, detailed fur textures, and cinematic composition. Sweeping landscapes, complex action sequences, intimate character moments, all rendered with a level of detail that makes you do a double take. This isn't good for AI anymore. This is just good. Real-world applications. So what can you actually do with this? Filmmakers can automate pre-visualization and storyboarding, getting rough video previews of scenes in minutes instead of days. Marketers can generate campaign videos customized for different audiences without reshoots. Educators can create dynamic visual explanations. Imagine a physics teacher illustrating concepts with custom-generated videos. And casual users? They can create entertaining content, personal messages, or creative experiments that would have required a full production team just a few years ago. Getting access, the Sora app, API, and what you need to know. OpenAI isn't just dropping this technology and walking away. They've built an entire platform around Sora 2, and how they're rolling it out is almost as interesting as the technology itself. On September 30th, 2025, OpenAI launched a new iOS app simply called Sora. It's currently available only in the US and Canada, and it's invite-based. You can't just download it and start creating. You need to verify your birthday, join a queue, and ideally get invited by someone already using it. This friends invite approach is intentional. They're building a community, not just distributing software. Now here's what makes this app different from every other AI video platform or social media app you've used. The interface looks like TikTok at first glance. Vertical feed, swipe to navigate. But it's designed with a completely different philosophy. OpenAI explicitly states they want to stop you from doom scrolling. For users under 18, infinite scrolling is completely disabled. Creativity nudges pause the feed periodically, essentially telling you to go make something instead of just consuming. Even for adults, the algorithm prioritizes content from people you follow or prompts that might inspire you to create, not just random viral AI videos. Currently, Sora 2 is free to use with certain limits. Compute is still expensive and constrained. ChatGPT Pro users get access to Sora 2 Pro, a higher quality variant with better resolution and fewer restrictions. ChatGPT Plus users get the free tier only. OpenAI plans to bring Sora 2 into its API soon, which will open up integration possibilities for developers and businesses. You can also access Sora 2 via Sora.com directly, not just through the mobile app. Every single video generated by Sora 2 carries visible watermarks and C2PA metadata, content credentials that identify it as AI generated. This isn't optional. It's built into the system to help viewers and platforms identify synthetic content. OpenAI has implemented a multi-layer safety stack where every prompt, every generated frame, and even audio transcripts get checked by classifiers. They've banned certain uses outright, anything involving child exploitation, non-consensual deepfakes of public figures, extreme violence. If a Cameo upload includes a minor, even stricter filters apply. In practice, these protections sometimes mean the system refuses to generate content that might violate copyright or other policies. Wired reported instances where benign prompts got blocked because they resembled copyrighted characters or music. Given that OpenAI is currently fighting copyright lawsuits, including one from the New York Times, they're being extremely cautious. It's a trade-off: safety and legal compliance versus creative freedom. What Sora 2 still gets wrong. Let me be clear about something. Despite everything I've just shown you, Sora 2 is far from perfect. OpenAI themselves admit the model still makes plenty of mistakes. Understanding these limitations is just as important as understanding the capabilities, especially if you're thinking about using this professionally. Visual artifacts and inconsistencies. Videos can still have glitches. Objects might jitter or briefly vanish. Some frames can look distorted or blurry, while adjacent frames are sharp. The dreaded flicker that plagued earlier models hasn't been completely eliminated. It's less common, but it's still there. This shows that true temporal coherence, making every frame flow perfectly into the next, remains an unsolved challenge. Physics isn't perfect. While dramatically improved, the physics engine in Sora 2's neural network can still break. The system card specifically notes, "We still see unrealistic physics and broken collisions as ongoing limitations. In edge cases, complex water simulations, glass shattering in slow motion, detailed hand movements, the model may hallucinate impossible motions. The physics priors baked into the model help a lot, but they're incomplete." Bias and representation issues. Like any AI trained on internet data, Sora 2 can reflect societal biases. Early analyses of the original Sora identified sexist and ableist patterns in generated content. OpenAI hasn't published detailed bias testing specifically for Sora 2, so users need to stay vigilant for stereotypes or insensitive content. This isn't a bug that can be patched. It's a fundamental challenge with models trained on human-created data. The copyright gray zone. Because Sora trains on web videos, it can sometimes create content that closely resembles copyrighted works. A generated scene might unintentionally mirror shots from an existing movie or game. OpenAI's filters try to block blatant copying, but accidental similarity is harder to prevent. This puts creators in a tricky position. Is your generated content truly original, or is it derivative enough to cause legal issues? Nobody has clear answers yet. Deepfake and privacy concerns. The Cameo feature is powerful, which means it's also potentially dangerous. If identity verification isn't airtight, someone could create realistic fake videos of people without their consent. OpenAI's design, opt-in only, verification required, revocable consent, helps mitigate this, but it's an area critics are watching extremely closely. The technology for sophisticated deepfakes is here. The question is whether the safeguards are sufficient. Overzealous safety filters. Sometimes the safety systems hallucinate violations where none exist. Benign prompts get rejected. Creative ideas get blocked. It's the classic AI safety trade-off. Make the filters too strict, and you limit legitimate creativity. Make them too loose, and you enable abuse. OpenAI is iterating on these filters, but finding the right balance is an ongoing process. Hardware and performance limits. Generating each video requires significant GPU compute. A 10-second clip might take noticeable time to render. Longer clips, beyond 30 seconds or so, might degrade in quality or be extremely slow. OpenAI offered a turbo mode for Sora 1 that traded some quality for speed, and there's a pro tier for Sora 2. But the fundamental compute constraints remain. This isn't instant like generating text. Patience is required. Competition is coming. Sora 2 is state-of-the-art today, but Meta is launching their Vibes app, Google is integrating their VO model into YouTube, and others are racing to catch up. Each platform will have different strengths. Meta integrates with social media. Google has massive scale advantages. Sora 2's differentiation is quality and the built-in creative community, but that advantage might not last forever. For businesses considering adoption, the key message is this: use Sora 2 with governance. Always review outputs for bias, errors, and potential issues. Don't assume generated content is ready to publish as is. Think of it as a powerful creative assistant that still needs human oversight. Looking forward, what this means for the future. So where does this all lead? OpenAI frames Sora 2 as a step toward models that can more accurately simulate the complexity of the physical world. By combining advanced AI with a social platform designed for creativity rather than consumption, They're trying to reshape how we make and share video content. Sam Altman, OpenAI's CEO, called this the ChatGPT for creativity. But he's also been remarkably candid about the risks. He's acknowledged concerns about addictive content, bullying, and mental health impacts. His promise? If the app doesn't make people's lives better after a trial period, they'll change it fundamentally or even shut it down. That's a bold statement for a company that just invested massive resources into this technology. For AI enthusiasts and technologists, Sora 2 represents a milestone in how quickly video AI is evolving. We've gone from silent 5-second loops just a year ago to cinematic 10-second clips with synchronized audio and coherent narratives today. It's not perfect. We've covered the limitations extensively, but it's a working system you can use right now. Over the next few months, we'll see how creators, filmmakers, and casual users actually leverage these capabilities. Will it replace low-budget filmmaking? Enhance special effects for major studios? Just give us funny memes and home videos? The answer probably includes all of the above. What makes Sora 2 particularly significant is that it represents AI that genuinely understands motion, physics, and sound. Not perfectly, but meaningfully. OpenAI suggests this kind of world simulation AI is a step toward more general intelligence, systems that don't just process language or images in isolation, but understand how the physical world actually works. Whether that grand vision fully materializes or not, Sora 2 is pushing the boundary of what AI can generate, and that's something worth paying attention to as we move into 2026 and beyond. The technology is here, the community is forming. The question now is, what will we create with it?